Hello and welcome back to our channel. Today's question is from the same paper as the question from the last video, which we will link in the descriptions below. Please like and subscribe and let's get started. This question is about a cat and mouse on opposite corners of an m by n grid. Each second they both move diagonally one cell, and the important thing to note is that they must move. Now the question asks for the pairs m and n for which it is possible that the cat and mouse can occupy the same cell at the same time. In other words, what values of m and n allow the cat and the mouse to visit each other? So the first thing to do is to colour in the grid like a chessboard. If we do this, and we plot out all the points that a cat can move to in one go, we notice that the cat must always stay on the same coloured square. The same argument goes for the mouse. In other words, if the mouse starts on a dark square, then it will always stay on the dark squares. Similarly, if it starts on a white square, it will stay on all the white squares. The same argument, of course, goes for the cat. This is what it should look like. On the left is the grid. You can see that the cat is in the middle. Now, in this position, the cat, moving diagonally one step, can only move to the different corners. These corners all have the same colour as the starting square of our cat. Now, let's have a good think. Our cat and mouse start in opposite corners of the chessboard, as described in the question. In order for these two corners to have the same starting colour, what properties must m and n have? Pause the video to have a think and restart it once you're ready. In order for the top right and bottom left corners to be the same colour, m plus n must be even. This of course means that m and n must either be both even, like 4 and 6, or both odd, like 3 and 7. If their total is odd, that is that one is odd and the other is even, then we find that the cat and mouse start on different colours. That, of course, means that they're stranded on their own colours and can't meet. What a disappointing tea party. Now, let's use a similar approach to last time. If we number the rows, 1 and 0 alternating, we find that the cat and mouse must move between different numbered rows every time they make a move, because they can't move sideways. Now, we need to remember that the cat and mouse have to move each second. What does this mean for the starting row number of our cat and mouse? And what height of grid do we need to satisfy this condition? Pause the video to have a think, and once you're ready, restart the video and see if your solution was correct. Since our cat and mouse have to end on the same square, which is, of course, on the same row as itself, our cat and mouse have to start on similar numbered rows. This can be verified by working backwards. If they ended up on a 0, then the step before that, they must have both been on a 1. One step earlier, and they must have both been on zeros again. The opposite is true if they both ended up on a 1. Therefore, using this method of working backwards, we can see that they must have both started on rows with the same number. The only way that this can happen is if the height is odd. This, of course, leaves us with only one choice. Since m and n must either be both odd or both even, if one of them is odd, then the other must also be odd. Therefore, in conclusion, m and n must both be odd. Thank you for watching. Thank you for watching. Please like and subscribe, and we'll see you next time.